Hello and welcome. Introduction. In this video, I want to discuss multiplexing two 7-segment display. Now, in my previous video, I have discussed how to interface a single 7-segment display to a Atmega 328 microcontroller. Here's the real physical single 7-segment display. We could, in theory, or practically, interface several 7-segment display to the microcontroller if the microcontroller have enough I/O ports. So let's say there are only two, assuming there's only two I/O ports with this microcontroller. I'm pretty generic about this for discussion purposes. So let's assume that this microcontroller has only two I/O ports. Now, if that is the case, then we have committed all the I/O ports to the 7-segment display, and there's nothing else you can do with the I/O ports if that's what we want to do. Now, a more common approach is to actually interface or connect the two display to one single input-output port. Now, the challenge in this is that since both 7-segment display share the same I/O ports line outputs, so the challenge with the potential problem here would be if I display a 2, the symbol 2 on this display, that same symbol will also appear on the second display because both of them share the same I/O port lines. Now the challenge is how do you get the two display to put on or display two different symbols? All right, so that would be the challenge. How do you get this to display, like for example, this display to display a 2, and then this display here to display a 3. So how do you get the two 7-segment display to show the two different symbols? Well, one solution is to use multiplexing. So what is multiplexing? Now with multiplexing, each display is turned on or switched on one at a time. But if the switching frequency is high enough with the persistence of human vision combined, it gives a picture or an illusion that the two displays are continuously active. So let's say you display a 2 on this particular display here, and then you switch over to display the other symbol, a 3, and then you switch it back to the other display. And if you do this fast, and if you do the switching fast enough, you will see two different symbols on the two display hardware. For this particular exercise of this video, you will need a 2-digit 7-segment display, and this is a common cathode version, and I got this from Amazon UK. I have left a link in the description below. You may want to check it out. If you're living somewhere outside of the UK, then you need to source or find this or whatever is suitable for this particular exercise. Now here is the circuit diagram. I couldn't find the appropriate what they call symbols with the my usual Tinkercad drawing tool for this two-digit what you call two-digit display. So what I did was to copy this from the data sheet and then hand-drawn this in using PowerPoint. All right, so let's take a look at this. So this is D2B, the B, the bracket in the B in within the brackets is the segment. So this B here is connected to this D1B of the first digit, or D1. I think this is D1, this is D2. So you need to comment them and then connect it to a resistor. All resistors, by the way, are 220 ohm, and this B segment is connected to pin 1 of the Arduino Uno. All right, pin 1 of the Arduino Uno board. And let's take a second one. This is segment A, D2. So you need to connect it to segment A of D1, and then take it to a resistor, a 220 ohm resistor, and connect it to pin 0, which is this one here. And these two here, the cathode is taken to pin 8 and pin 9 of the Arduino Uno. So which is 8, pin 8 is here, pin 9 is here, and then and so on. So basically you need to comment the segments that are the same together and then connect it to a resistor and take it to the appropriate pin as marked here. So right now the pins here that you see are the pin numbers on the Arduino Uno board. And here what I've done is I have included in brackets next to the pins these what do you call numbers here, like for example PD2 attached to pin 2. PD2 here is the port D pin 2 of the 8 mega or 80 mega 328 microcontroller. So the brackets are the one referring to the 8 mega 328 microcontroller pins. All right, so don't get them confused, but it is important. All right, because when it comes to programming, we will be referring to these pins here, not the pin number of the Arduino board. All right, so remember the 8 mega 328 pin numbers. All right. Okay, I think it's time to take a look at the code. There are two examples in this particular video, and this is the first example number 1. And here's the code for example number 1. This include directive here is standard. So whenever you start a solution or a project, this is a default setting, and this is useful. This io.h if you're using things like DDRB and DDRD and so on. Though this you need this if you're using this. Anyway, it's by default anyway. And here we define the speed of the processor or the microcontroller, and then we need this delay.h because we'll be using the delay function in the code later on. Here I declare two variables of the type int, MSB index and LSB index. These two variables are used to access the elements of the array. So I've jumped the gun here a bit. So this is the array, and I call it symbol. Basically, these are the definition for the numeric values like this would be 0, 1, 2, and so on. So the index here, LSB index, MSB index, is used to access these elements. And here I have set them, initialize these two variable to 0. And here we are, before we get into this, so this is I repeat the dual display diagram here. So here, D1 will be the MSB, D2 will be the LSB, the least significant byte, and the most significant byte. And to select that, so these are the two cathodes here, and that is actually being used here, sorry. So with the while loop, I have port B. Remember, I've already set port B as an output mode. I use 0, 2. That will select the MSB, which is this one here. All right, and then output the symbol to this MSB, and then do the delay. Right, this 8-0, you really need to figure out yourself. There's no rules of this, but you'll see what I mean when I go into the demonstration later on. And here I'm selecting LSB. All right, we send this out, and that will select this and deselect this. All right, so then you get the symbol from the array, display it, do a delay, and then here we increment LSB index by 1. That will move the index to access the next element in the array, and then check the index and see if it's equals to 10. If it's equals to 10, then you reset it to 0, and then here you increment the MSB by 1 so that it can access the next symbol for this. Right, and then here we check for MSB. If it's greater than 9, you reset it back to 0. All right, so basically this is the code for example number 1. Okay, so welcome to my AppML Studio 7. So I've put up the code here, and as discussed before, so I'm going to go through this. You know what it means by now, since we've discussed it earlier in my presentation. And here, what we're going to do is we're going to build the code first. So build. Yeah, so we have built one succeeded. All right, so what I'm going to do is, as per usual, I'm going to go through this using single step first. So go to debug, start debugging and break. So if you get this message, don't worry, click continue. Simulator, all right. If you see the asterisk here, you need to save it. Close this, and now you're good to go for debugging. All right, before we do that, let me just comment this delay out because it interferes with the debugging session later on. Oh, I need to redo this again, sorry. So rebuild. All right. Okay, so we're good. So start debugging and break again. So the yellow arrow is here, so I'm going to use F11. DDRB first, so DDRB, look for what? So DDRB, yes, this is FF, so we're setting port B to output, and E, right, is also FF, so both the ports are now set. Then we initialize the array, and we set MSB to 0. And if you want to watch that part, so go to debug, Windows, go down, look for watch 1, and you type MSB index. Then you want also LSB index. I don't know why this came out. Okay, I pressed the wrong key. So LSB index. All right, okay. Let's see what happens. Nothing seems to happen, and now I'm stuck here. All right, MSB. I see they are all set to 0. Now port B. So let's read port B. All right, so we do single step, and then we have port B, so 0, 2, and then port D. So that will select the MSB display. Now I'll go to port D. All right, so port D, 3F. So that's the first one here. So we call the first. So we access the first one, and then now try to switch over to the other display, the LSB. So port B. All right, port B, we have now 0, 1. So let's select the LSB display, and then we output port B. Port D, that's 2B. All right. Okay. So that's 3F there, so that is a 0. Okay. Now we increment LSB index. What's this one here? So we're going to move the index to point to the next one and check is LSB index equal to 0. So this will not be true yet. So it's gone back up now because this whole bunch of, because this is not true yet. All right, so we skip the whole lot, go back up, select the MSB in display again. So port B, D for the output, and then port B again, which is selecting the next one, the next, switching over to the LSB. All right, so now we select, and then we move on to the next, access the symbol. It's 06. Is this one here? All right, and then is it increment index by 1? So it's 2 now, as you can see. And then is it 10 yet? No, and you should go back. And so it will do this until it finishes its access to all the elements of the array. Okay. So that is the single step part of this demonstration. Okay, so let's try to upload the code to the Arduino Uno. Now, before we do that, let me just show you my setup. All right, so here is the my setup, and here are the dual 7-segment display, and right at the back is the Arduino Uno R3. All right, so this is my particular setup. Let me go back to the ML Studio. I have reset the Arduino, the ML Studio 7. So let me just build the code again. So build it. Yeah, so it should be no problem. And so this one succeeded. So now what we're going to do is I'm going to try to upload the code to the Arduino Uno. So I've already set everything up, so I'll just press this, you select that. All right, so the code is uploaded. Things happening. Thing doesn't seem to be working. So let me just try to figure it out. I'll get back to you in a moment. All right, I'm back again. Now I know why, because I've commented out the delay. So let me just take the delay out. All right, let me take the delay out. Sorry, let me uncomment the delay. Now, let me just save it. Let me just clean the solution. So, and then rebuild the solution. All right, so let me try uploading it again. All right, let's see. Let's see if we have more success. Yep. Can you see the? Oh, wait a minute. Can you see now that it's running? Let me just try to minimize it. Yeah. So can you just basically see? So it's now counting from 1, 21, 24, 28, 29. So let it run. 55, 60, 68. All right, 90, 90, 99, then it goes back and starts all over again. All right, so, but can you notice the flickering? That is because the effect of multiplexing. You try to switch between the two display. All right. Okay, so I'll stop the demonstration here. And okay, so so in this second example, we'll try to improve on the flickering effect that we have witnessed or observed in the first example. All right, that is due to the multiplexing technique algorithm that we use. So let's see if we can improve and reduce the flickering effect. So let's move on, and here we are. I think everything it's almost identical to the earlier one, except for this one, I'm using an interrupt. What do you call function in my? So I'm going to use the interrupt function in my code. So that's why I need this interrupt.h header file. All right. Now, if you're not too familiar with the what do you call interrupt, I recommend that you go visit my previous video 60, on using timer 1, the Atmega 328 timer 1 in the normal mode. So go have a look at that one and see if you could lean anything from it. And then I think there's another video on internal interrupt. I can't remember the video number now. I think it's greater than 60. It should be 61 or 62. Check those two videos out, 60 and 61 or 2. I can't remember now. Go check those videos out. All right, but it's not that difficult to understand, so not to worry. So here I declare they call the functions that I'm going to use. So I'll be using something called MSB display function with these two parameters, and then something called LSB display. I think the name itself is self-explanatory, and the setup timer of timer 1. Sorry, the setup of timer 1 here. All right, so these are the three functions that I'll be using, that I've written. Then declare the LSB index and MSB index as symbol array. And here is the main what they call function. Again, if you look at it carefully, these four lines, sorry, are basically the same. So port B and port D will be set as output into output mode. These two lines is the initialized MSB index and LSB index to 0. And then here we set up the timer 1. All right. Now, again, I'm using the while loop. So I'll call this function to display the MSB symbol, and then here I'll call the LSB display function to display the LSB symbol. Here we check and to see if is LSB index greater than 9. If it is, then you reset it to 0. If not, you just increment this, check this one also. If it's greater than 9, you reset. All right, basically pretty straightforward. In fact, this part here is almost identical to the example 1. So let's look at the functions that we set up. This is the setup timer 1 function. I'm using this value here, F0 FBE. This will give us a 0.5 second delay at 16 megahertz. And these three lines here basically, these two lines, sorry, basically set at the timer mode at 1024 prescaler. Then here we enable the interrupt overflow. And then this SCI will do the enable global interrupts. So basically this is pretty standard as discussed in my earlier videos. So if you're not too familiar with it, just bear with it for a little longer. Go check out my previous videos. And then, okay, yeah, then let me just move on. So MSB display and LSB display function. If you take a closer look at this, all right, you can see, ignore these two lines here, the one that is commented. This will select the MSB display. This will display the symbol of MSB. A short, very short delay here. Then LSB display selected here is selected by this code, this line of code here. Then display the symbol, delay, give it a short delay. Notice the same. Show a very short delay here, and basically nothing new here. And this is the interrupt service routine. Once the interrupt is triggered, then we increment the LSB index. And then once it's done, it will then reset the timer value. All right, we need to do a reset before we allow the interrupt service routine to surrender it back to the main function. All right, so this is basically just to reset the value. All right, so okay, so this is the code that I've talked about earlier. So without further ado, let me just now go to debug session. Just give me a minute. So before we do that, let me just clean the solution and then rebuild. Okay, so we're good. So these are all the things that we have covered earlier. These are all my what they call functions that I've written and that I'll be using. These are the variables. So LSB index and MSB index, and this is the array with all the symbols. I call it symbol. And then, yeah, okay, so let's go to debug, start debug and break. Okay, so so the first port here is DDB. Okay, so I'm going to use F10. All right, so yeah, okay, then port D, DDRD, so that's it. And then here I've already set up in the watch window one, MSB index and LSB index. So initialize them. So it's done. Then we set up the timer one. I'm not going to step into it, so I'm going to step over. So it will execute. Now it will then display. This line here will display the first symbol onto MSB. Yeah. That's B, sorry. And then port D. Oh no, so sorry. Yeah. Okay, so DB. Okay, so we have it here. And then we check, is it greater than 9? This is definitely not greater than 9 because we just started, so it then goes back and do the next one. Next one, is it greater than 9 yet? No. And then so we'll repeat this until we get to 9 and then reset and so on. Just like we did earlier, except that to increment LSB index, we're using the interrupt to do it. Right? So it's not easy trying to simulate interrupt in the simulator. So all I can show is that when we demonstrate when we upload the code, you will see the effects of it. All right, so we're going to stop here for the debugging session. All right, so let me just show you the setup again. All right, so here's my setup for the physical setup. So it's exactly the same, but the code is just the only thing that is different is the code. So now I'll upload the code. What am I doing? Okay, so we're going to upload the code. Okay, so all right, so it's gone a bit crazy. Oh yeah, because I didn't put the delay back in. So so let me just stop that for the time being. All right, let's go back to the code. You see this delay here? I didn't put it back. So now let's put it back. So if you ever do debugging with this thing, if you are commenting, or make sure you take the comments out. All right, so now clean the solution, build the thing again. All right, so upload the code. All right, here we go. So now it's now running. Can you see the difference? This time the display is a lot more stable, less flickering. You can see in the background it's kind of flickering a little bit, but it's a lot better. A great improvement over the previous example. All right, I'm going to let it run for a little while so that you can see the difference between this one and the first example. All right, now it's up to almost halfway there. Okay, so 60, 70. You can slow this down by changing this value here, the TC and T1 value. All right. Okay, so that's it for this particular demo. I hope you enjoyed the demo. Okay, so we've come to the end of this video. I hope you have found the content useful, and thank you for watching, and I'll see you in my next video. Bye.